Ladies and gentlemen, welcome back. Today we're going to be looking at, continuing looking at the special right triangles, but in particular we're going to tie trig into the special right triangles. Alright, so remember from last time, if you have a triangle, two of the sides are equal, we know that two of the angles have to be equal as well. Alright, so we have two angles that happen to both be 45 degrees. We know that because the angles need to add up to 180 together. Alright. Remember that if these two sides are, whatever these two sides are, the x sides, the last side is going to be equal to x times the square root of 2. All right? So if we want one of our missing sides, we could go ahead and divide both sides by square root of 2, and we could say something like x is equal to 7 divided by square root of 2. Tossing that in your calculator, go ahead and do that. You should get a 3 point something. All right, I don't remember off the top of my head. I think it's 3.494, somewhere around there. Should get about that for that side. For the 30, 60, 90 triangle, on the other hand, remember that we have some special triangles. And by the way, if you don't remember this, look back to the previous video. All right, look back to the previous video on special triangles. We can label a few of the sides. I think we used the letter S last time. We have a shortest side is going to be letter S. Hypotenuse is always 2 times whatever S is. And then the last side is going to be equal to S times square root of 3. All right? You can pull the same type of thing off with this problem. I see that we have a 12 equals S times root 3. You could divide both sides by square root of 3. I'm going to do that on my calculator. I recommend you do the same. 12 divided by square root of 3. And you're going to get about a 6.928. All right. S value after you divide root 3, it's going to be about a 6.928. Well, how do you get this last side? You can go ahead and double it. You can double this side here to get this last side. So that's going to be 2 times 6.928. We'll multiply that by 2. You're going to get somewhere around 13.856, somewhere around there. Always ask yourself if these answers seem reasonable. 12, if this length is 12 right here, does it seem reasonable that that's about a 7-ish or so? Yeah, that seems pretty reasonable to me. If this is a 12, is it reasonable that the hypotenuse is 13, a little over 13, almost 14? Yeah, that seems pretty reasonable as well. Now, in order to simplify some of these terms, we're going to do what's called rationalizing the denominator. We mathematicians do not like to have a square root in our denominator. So here's what I'm going to do. You can multiply any number by 1, right? You can multiply any number by 1, and it's the same number. You can also multiply any number by something that's equal to 1. Like for this one, I'm going to go ahead and multiply it by square root of 3. Oh, here we go. Square root of 3 over square root of 3, which is also 1. All right, here's what's going to happen. On the top, 5 times root 3. We have 5 times root 3 here on top. And on the bottom, think about square root of 3 times square root of 3. Well, square root of 3 times square root of 3 is going to be square root of 3 squared. Square root of 3 squared, squared and squares cancel out. It's just going to be a 9. Or, excuse me, it's just going to be a 3. Essentially 9 squared, square rooted. It's going to be a 3. So our final answer here, simplifying this out, rationalizing it, would be 5 root 3 over 3. Same thing can happen here. We can go ahead and multiply both the top and the bottom by root 5. Top and the bottom by root 5. That's going to leave on top 8 root 5. And on the bottom, root 5 times root 5 is just 5. So we would say that our rationalized version of it, the one that doesn't have a root in the denominator, is 8 root 5 over 5. Now, how is this helpful? Let's look at some trig. Let's look at some trig examples. Pretend like this right here is a 45-degree triangle. All right, we have 45 degrees up top. We have 45 degrees on the bottom, and we have 90. All right, it's 45, 45, 90. Suppose we have one side of 1. That means that this other side is also 1 because angles are equal. That means sides are equal as well. According to our special triangles, we can take any side length, multiply it by root 2, get the hypotenuse. I'm going to do that similarly right here. I'm going to multiply it by root 2. 1 times root 2 is just root 2. There's my side length. I can do that with the other triangle as well. Here's a 60-degree angle. All right. Here's a 30-degree angle. I'm going to label one of my sides 1 according to special triangles. And remember, if you're having trouble with special triangles, check out the last video. Hypotenuse is always double the size of the short side, so 1 doubled is 2. And then the last side is whatever the short side is multiplied by root 3, so 1 times root 3 is just the square root of 3. All right, that's just the square root of 3. Now we can start putting in values here. All right, we'll start with the 45-degree angle. 45-degree angle up here means we have an opposite side here, we have a hypotenuse on this side, and we have an adjacent. All right, I know sine, according to our SOHCAHTOA. Sine is always opposite over hypotenuse, so 1 over root 2. We say that the 45-degree angle is 1 over root 2. If we want to simplify that by reducing the radical, I'm going to multiply this by root 2 over 2. So on top, I'm going to get a root 2. And in the bottom, root 2 times root 2 is just a 2. This number is equal to root 2 over 2. All right? That's our final answer. Sine of theta is equal to root 2 over 2. You can check that on a calculator if you'd like. Sine of 45 degrees, put that in your calculator. Sine 45 should give you a 0.707 something. Same with square root of 2 over 2 should give you about a 0.707 something. Notice that cosine is adjacent hypotenuse. It does 1 over root 2 again. So same exact thing is going to apply where you're dealing with the same exact numbers, root 2 over 2. And in fact, tangent, look what happens with tangent of 45 degrees. Our opposite's 1, our adjacent's 1, tangent's opposite over adjacent, so 1 over 1. Our value is just 1. We can do similar things over here with the 30, 60, 90 triangle. I see relative to our 30-degree angle, we have 1 is our opposite, 2 is our hypotenuse, root 3 is our adjacent side. So when we're dealing with the 30-degree angle, sine is opposite 1 over hypotenuse 2, 1/2 in other words. And if you check on your calculator, sine of 30 degrees, it is 1/2, 1 over 2. Cosine adjacent root 3 over hypotenuse of 2. I'm going to write that out. Root 3 over 2. And tangent, opposite 1 over root 3. Which, if you go ahead and turn that in as well into a rationalized form, I want to go and multiply both sides, top and bottom, by root 3. That's going to be equal to root 3 over 3. All right, root 3 over 3. What's cool with the 60-degree angle is you only need to flip the opposite and adjacent side. Root 3 is now opposite, 1's now adjacent. So a couple values are going to flip here. I'll switch over to blue. Cosine is now, or sine now is rather root 3 over 2. Just like cosine was for the last one. Cosine of 60 degrees is adjacent over hypotenuse, 1 over 2. And then tangent is just going to be root 3 over 1, which I can just write as root 3. Notice a few patterns here. These two match. These two match. These two are the exact same. And these two are upside down versions of each other. For this class and then for Algebra 2 and Pre-Calc respectively, you're going to need to memorize these values because we're going to have a mastery quiz on this very soon, memorizing these values. All right? So give that a shot and we'll move on to the next slide. All right, so let's look at an example of how we can use this. We have a 45-degree angle. I want this side, the adjacent side. We currently have the hypotenuse. if we were using the shortcuts that we have been in the past, well, we can take 15, divide by root 2, and we should get, in the end, we should get some answer that looks like 15 over root 2. All right, that should be the answer we get at the end. Let's check and make sure. We're dealing with adjacent hypotenuse. That's going to be a cosine problem. Cosine of 45 degrees is equal to adjacent over hypotenuse, so x over 15. All right, x over 15. Cosine 45, according to my table, is root 2 over 2. Square root of 2 over a 2 is equal to on x over 15. All right, we can cross multiply here. On the one side we get 2x. On the other side we get 15 times root 2. And then we can divide both sides. All right, then we can divide both sides by 2. And we're done. This answer right here is your final answer. We did not use a calculator for that note, and for the mastery quiz we will not use calculators. But we got a final answer. 15 root 2 over 2. Now you might be asking yourselves, Mr. Reece, this doesn't make sense. This answer does not match up with the answer that we assumed we'd get. Well, try rationalizing this denominator. I'm going to multiply by root 2 over root 2. All right. On top, we're going to wind up with 15 root 2. And on the bottom, root 2 times root 2 is just 2. So we really do end up getting the same exact answer that we got. All right. With the shortcut method over here or with the trig method, you can get the same answer. If you have a moment, go and pause the video. Try to solve this one on your own. The answer, I mean, if you're going to do the shortcut method, the answer is 7 times root 2. 7 times root 2. Something interesting happens here, though, with the values. We'll still use cosine because we have the adjacent, we have the adjacent up here and the hypotenuse. We'll still do cosine 45. This time, adjacent over hypotenuse, we have a 7 over an x. I know cosine 45 is root 2 over 2. Root 2 over root 2 equals the 7 over x. Excuse me, once again, root 2 over 2, there is not a square root here. Root 2 over 2 is equal to 7 over x. We can cross multiply this. 2 times 7 is 14. X times a root 2 is an x root 2. Excuse me. I accidentally cleared that with my sneeze. My bad. 14, where were we at? 14 times x root 2. I'm going to divide by root 2 on both sides, so we really have 14 over root 2 is equal to x. All right. Now I'm going to simplify this, and this is going to simplify pretty far. All right. I'm going to rationalize it by multiplying by root 2 over 2. That'll end up giving me a 14 times root 2 on the top. And then on the bottom, maybe I'll switch over to red here quick. 14 times root 2 on top. On the bottom, I'll just have a 2. 14 and 2, they're going to cancel out a little bit. 14 over 2 is a 7, so this is really just going to be 7 root 2 then. All right, it's just going to be a 7 root 2, which is exactly what we thought with the shortcut method. We have a 7 for a side length multiplied by root 2 to get that hypotenuse. 7 root 2. Let's look at one last example here real quick. We have a side of 12, side of A, side of B. We want A and B. We want to solve for both of those. I know that this is our hypotenuse down here. I'm going to completely ignore this 60-degree angle and concentrate on the 30-degree angle, all right? That's our opposite. That's our adjacent. I'm going to go ahead and do a problem using the adjacent and the hypotenuse first. Cos of 30 equals the adjacent 12 over that A side. All right. And I'm going to continue that problem right down here. Cosine 30, I know, is square root 3 over 2. So that is equal to 12 over A. I'm going to cross multiply. So 24 is equal to A root 3. All right. Dividing both sides by root 3, we're going to get now A is equal to 24. Excuse me. 24. Let's undo that. 24 over root 3. And if we want to simplify that, rationalize the denominator, we're going to get 24 root 3 on top and just a 3 on the bottom. That can be simplified a little farther now. I know 24 over 3 is an 8. So this side here is really just 8 times square root of 3. 8 times square root of 3 is our final answer. This side's 12. Hypotenuse is 8 times root 3, which is a, what's that, like a 14 something probably? 15, 16, 15 something. You can do a very similar method, although I'm going to show you a shortcut here. If you want to do some trig, try some trig. I'm going to switch over to blue with the opposite side and the adjacent side. You'll end up doing some tangent. Instead of doing that, though, hypotenuse and shorter side. I know there's a trick. Hypotenuse is always double the length of the shorter side. So this side just needs to be half of 8 root 3, which is 4 root 3. All right, you'll get this exact same answer if you do some trig, but that answer is going to be just 4 root 3. As usual, if you have any questions on this, do let me know. Otherwise, we'll have a mastery quiz next class. Here's one to try out if you'd like to try it out. Give it a shot. You should get about a 2.5 for one of the sides and then 2.5 times root 3 for the other side. Unit circle is going to be something you'll see next year, so I'm going to kind of glaze over that for now, but you'll see that quite a bit next year. Try to memorize your trig values by next class. Give that a shot. Have a great night.